Hello and welcome to m253 Calculus 3 here at Cañada College. My name is Lapuz. In this video we will take a look at section 5.3. This is one of the homework problems and it's asking us to evaluate the integral over the region R. So the integral is 7 times 1 minus x squared minus y squared dA, and this is a double integral over R where R has the region R has polar coordinate R values going from 4 to 5 and theta going from pi over 2 to 5 pi over 4. And so I was drawing this. I was trying to draw this and try to capture the big picture, but this thing goes down in the negative direction. So that's one big issue. And it goes down to actually, I had to adjust this to go all the way down to negative 200. So for some R values that you put in, it has to go down really far. And I tried to capture this. I couldn't capture it completely and accurately because right now I'm unable to use polar coordinate limits for Desmos. So this is about as best as we can get. And so the result that we should be expecting would be a negative value. And because the z values go down to 200, this will be a large negative value. So that's about what we have. All right, just to get you the details of this, we have the surface itself is the function. Z is equal to 7 times 1 minus x squared minus y squared. We have r is equal to 4 and r is equal to 5 as these polar coordinate pieces of a circle centered at the origin. These go from pi over 2 to 5 pi over 4. And what we're actually looking for is the volume of this cylindrical drop from the x-axis or the xy plane all the way down to the surface. And again, because it's going below the x-axis, we should be expecting a negative value. And also the fact that this is the negative z values go down to close to negative 200 means it should be a fairly large z values, especially when we're looking at the radii being 4 and 5. Okay, so that's what we have, and we just have to set up this integral. Notice that the integral is in Cartesian coordinates, but the limits are in polar coordinates, so we might as well go all the way to the polar coordinates, and we're going to find the integral. And we usually want to have the outer integrals to be the theta when we're going to polar coordinates. So we're going to go integrate lower limit pi over 2, and then upper limit 5 pi over 4. And then inside, we're going to do another integral this time. We're going to go from 4 to 5. And now your integrand is going to be 7 times 1 minus x squared minus y squared. But remember that we're changing this into polar coordinates. So instead of x squared plus y squared, we're going to do r squared. So this is going to be r squared instead of being x squared minus y squared, or minus x squared minus y squared is negative r squared. Now the dA, remember, has to get replaced with r before we do the dr d theta. So r is another variable here, and then we're going to go dr and then d theta. And then we see that we have a negative value, which kind of corresponds a little bit with the drawing. This thing went all the way down, and we got negative values of 1,447, which is rather big for a negative value. Okay. All right. So I hope that helps, and good luck.